we're going to start today multi-step equations. If you were to see the kind of equations we'd be doing by the end of the class, a lot of you would be very upset about how could we possibly do that. But all we rely upon is that you did the single-step equations with a good foundation and solid, clear basis of what you wrote, and not a bunch of shortcuts saying, I know the answer's 3, get me out of here. So we're going to look at how to solve multi-step equations, and it's going to involve what I call a moving target. The target was defined when you had a one-step equation. I could write the number, we could shoot for that number. If we got it, we hit it, we knew it, it was there the whole time. This is not going to be that way. There is a number that makes the two sides of the equation equal the same target, but we don't know the target till very near the end. So solving multi-step equations involves the expressions on both sides of the equal sign hitting the same target. So that sounds like how it started. But you don't know the exact value of the target. Until the end. We know we're shooting for the same target, but we don't know what it is that we're shooting for. And if we both meet at the same destination, then it works. And that's what happens when there's a multi-step equation. A lot of times it won't have a target. Sometimes it will still have a target that we look for, but the target's going to feel like it's moving around. I want to show you what I have in terms of steps to get through this. Number 1, get rid of any parentheses. That does not mean drop them. Like, I don't like them. He said get rid of them. They're gone. Usually it's distributing, properly distributing a negative if necessary. But I'm going to write here that it's usually distribute. Okay. The next step. On one side of the equals, you can cover up the other side. Combine like terms. And then on the other side of the equals, combine like terms. We could have been doing this a little while ago as far as the class goes. Once we learned how to distribute and combine like terms in an expression, then you were able to do that and make it look better because you wouldn't have like terms sticking around and you sure wouldn't have parentheses still sticking around. And that happens here, but you treat the left side and the right side completely separate from each other, so it's like the right side doesn't even exist until you've cleared the parentheses and combined the like terms on the left. Then you go over and clear the parentheses on the right and combine like terms on the right. And then they'll meet in a much more workable situation. Get the x terms all alone on one side of the equal sign with the number terms all alone on the other side of the equal sign. Some of you will come to me with this idea of let me get everything on one side and 0 on the other. Bad idea. Is it terrible that it's impossible to get back to the right answer? No. But you're working at least twice as hard, risking at least 2 to 3 times as many mistakes, and it's completely unnecessary. The goal is to isolate the x, to get the x by itself and point to the solution. The way to do that is to get x's on one side, numbers on the other, or x's on one side, numbers on the other. It doesn't even matter which side has the x. we must have x on one side, all the x terms, and all the number terms on the other. So to do this, I'm going to say what I recommend. Get rid of the, what I call, worst bank balance for x. What? If you do this, you will never have a double negative to deal with your division. Sometimes you'll have a negative answer, sometimes you won't. But if you do this, allowing x to either be on the left or right side, and you get rid of the worst bank balance, it will always, and in math we don't get a lot of these, always it will produce a positive coefficient for x, which means you won't get that idea that says, oh, I got negative 3x, let me add 3 to both sides. A mistake commonly made by people that's easily avoided. If that 3x was positive, you're not as likely to think, let me subtract, because I know I have to divide. So this is a recommendation, not a requirement. But many of my students that take the recommendation do find it easier to get through this with fewer chances of mistakes, because they think carefully about how they're going to act, and they don't just say, I hate math, let me get this over with, keep it going, keep it going, keep it going, here's an answer, I hope it's right. Okay? You're going to stop, you're going to think, you're going to make a good decision. When I say you make a good decision, I don't mean you have to decide to do it exactly the way I would. But what I mean is you work on the process of looking at what you have and deciding how to maneuver at that time based on the skills you have. That's why I think that it's very important to develop the concept of what do I do before I do it, and how can I use that in the future? Because learning how to look at a situation and then move into it is much more important than properly being able to divide two negative fractions. And so thinking about this and watching how it works will be very helpful, so that you're slowly approaching the problem until you get to a situation where completing the task is faster, easier, and less risky. So we'll hang on to that idea. Number 4. Isolate the variable. Getting rid of multiplication with division or a reciprocal. But isolating the variable, once you've gotten x on one side with maybe a coefficient and the numbers on the other turned out to be just a single number, now you're going to divide. If you have an integer sitting in front of x, it may be positive, maybe negative. In our case, worked on keeping it positive. Divide both sides by that integer, or multiply by the reciprocal of the coefficient, which is that fraction that you hate so much. You know, it's a fraction. What's it doing here? Still, reciprocal multiplication will get us away from that fraction. 5. Reduce the variable side. I'll say again to x, but to whatever the variable is. They'll definitely become x. 6. Simplify the number side. To your solution. Check your solution. Check what you think is the solution in the original equation. Not your favorite, not the one you worked hard for. It's got to be in the original equation, because a solution only works worth anything if it works in the original equation. So I'm going to take you through this process. And then we'll be able to solve some pretty long things that take up a lot of space problems down to finding x, and then we'll be able to drop their values into the equations. And what's really important is I'm not going to do a bunch of problems here is that in the homework, you're going to do a lot of problems. And so the homework video is one of the most watched homework videos of the course, is the one that goes with lecture 8, homework 8. Because I go through probably, I don't know, what are there, 19 problems? I probably go through 18 of them. Because there are so many little pieces that can come along and make it a little bit harder, that this is our general design that'll work all the time. I call it a recipe for solving an equation that has no powers, right? Has one variable and doesn't have any powers greater than 1. Works all the time. There are a couple weird things. When you get a solution and it tells you that, you know, two numbers are like 0 equals 0. What is that? If 0 equals 0, that's always true. That means it does not matter what number you put in, it'll always work, because there's no way you're going to make it wrong. That's one weird situation that happens when the variables completely cancel out. The other one, when the variables completely cancel out, is you might get something like 0 equals and some other number, whatever the other number is. 0 equals 12, 0 equals negative 72, 0 equals negative 57 over 42. 0 never equals that, and that means no number in the world can get you there. And so those two things, they can come up every once in a while, and they both come up in the weird case when the variable has the exact same coefficient on both sides, and you do what you're supposed to. You're like, I guess I got to subtract 5x, and they both go out. Then you're either getting it's always true or it's never true, but you're not going to find it to have a single solution. Again, you can take a picture of this, you can get a screen grab of this and put it to the side of your computer, okay? You can open up another window and freeze the video at this point, but you want this, plus I'm thinking you want to have it in your notes. If you have it in your notes, then you'll have it ready to go to like you were in class. But you can go back to the video and find it again. That's kind of nice. So here's a classic example of what teachers will have their students do to solve a two-step equation. Or, you know, 2 is technically the shortest of multi-step equations. A single-step equation is the one where you do one thing and you got the solution. Here we're going to have at least 2 steps in these multi-step equations. What we want to do, my general thought process, is get the x's on one side and the numbers on the other. If you have this, where 3x is positive 3x, I like that, and no x's on that side, then that leads right to this first occasion, where we think right now that the target is 12. And it is. Target for the whole problem, when we're done with it, will be 12. We're looking for plus or minus interference. Okay, so now what we've got here is plus or minus interference is the first thing that we get rid of. We're trying to get the x's on one side, the numbers on the other. And so we can't say that's x minus 1 and the only interference is minus 1. We have plus or minus interference. Here is that we have plus negative 1. So the inverse to that is going to be plus positive 1. So we go to where the numbers are in each case and we add 1. Let me rewrite the equation so we have a clean version to go back and try. 3x plus negative 1 equals 12. I wrote the problem wrong. Boy, that's crazy. We could start the tape over, but I'm not going to do that. I want it to be 11. I want it to work out nicely for us. So this is 11, and this is 11. And that means I got to switch my target. If you knew the target, splitting in the target space was a 12 for that moment, now let's say it's 11. It'll just work out better so we can focus on the algebra and not too much on the arithmetic. Okay, my bad on that, but let's see. All the rest is good. We're going where the numbers are, and we're going to add 1 in the number column on each side. What does that do? It gets rid of the numbers on the left, but it leaves numbers on the right here to become 12. Sometimes the numbers will become 0, and that's okay. It works its own way out. If we have some number that's 0 and we divide 0 by a number, it actually, the calculator, our own work, can all show that's okay. We get into trouble when we have 0x, and that's when those weird situations come up. But what happens here now is 3x equals 12. That's what my thought was. The target is moving. Now the target for the whole thing is to be 11, but now the new target seems to be 12. It's like a moving target. But all we have here now is 3x equals 12. That side has the variables, that side has the numbers, which is great because now our interference here is 3 times x. Interference here is times 3. We're going to divide both sides by 3. I'm going to write the 3x equals 12 again. And I'm not going to write the target interference for you, but I am going to use the colors. Now we're trying to hit a 12. And we're trying to do it when we've got 3 times our number. So what we have to do is divide by 3. And what we've done so far is if there were parentheses, we would have gotten rid of them. If there were like terms on each side, we would have gotten rid of them. They're not, but as they get harder, the problems will bring that into play. We're already set with a recipe that does that. Now, we've got, what we did was add 1 to both sides to get it so that one side contains the 3x and it's the only x term, and the numbers are all on the right side. It doesn't have to be those sides, but 1 on each side. And now 3x has to equal 12 because the old thing that we had over here was already 1 too low, so we bring it up by 1 on each. We got 3x equals 12. Now we're looking at this, which is now a one-step equation, but it took a step to get here. And that's going to get me x equals 4. 3 over 3 is 1 with an x, and 12 over 3 is 4. And now we need to see if it works in our original equation, where the target was 11. So we have our 3, our numbers coming in, minus 1 is supposed to equal 11. And I put my 4 here, and I get 12 minus 11, which would be 12 plus negative 11, gets me 1. 12 plus negative 1 gets me the 11, and I've got it. And therefore x equals 4 is my solution. Now, a lot of teachers will assign maybe 5, 6, 7 of these in the homework and just hope you get in the that nice pattern of repetition and all that. Nah. We're going to go for the concept of getting x's on one side, I don't care which, numbers on the other, with the x coefficient to be positive. So I have another problem for you. Should fit up here as well. Remember that what it says in the rules is to look for parentheses first, get rid of them. Look for like terms on either side, get rid of them. Then go after x's on one side, numbers on the other. And I'll get them more challenging as we come along through them. Okay, 20 minus 5m equals 65. Still has a target of 65, but it's got this 20 here that's causing my letter not to be alone. And the way we go about it, if you look at the steps of our process, is we use plus or minus to get a cancellation of addition or subtraction first, and that will get it so that one side has our letters and the other side has our numbers. Now I'm going to go ahead and leave the negative 5m here on our work, but if I want to leave the negative 5m right where it is, because it's my only m's, 20 is my interference, and it's positive. So what I'm going to do here is I'm going to add negative 20 to each side. What does that do? Well, 20 minus 20 is gone. I won't even write it. Here I have plus, which I no longer need, and then I have dash 5m equals. And over here I've got 65 plus negative 20, subtract and get 45, strong on the positive. Right, 65 minus 20, 65 plus negative 20 gets me to 45. Now what's going on here? Let's get a look. This is where I think it's important that we can see what we have. Let me write that back in black and create the new one. Here I'm going to write negative 5 times m equals, and in this case I'm seeing the 45 as the new target. This is the part where we might get in trouble because of the dash on the 5. We don't call it minus 5, it's negative 5. It's negative 5 times m. So the blue, negative 5, between it and m is going multiplication. And so, we have to divide by not just a 5, but negative 5. We're not interested in finding a value for negative m, which is what we would get if we divided both sides by 5 and said, don't worry about signs. The opposite of negative 5 over 5 with an m is 1m, and then is eventually m. This has a dash in front of 45 over 5. This has a dash in front of 9 over 1, and gets me the negative 9 is my answer. So, that's not bad. That's quite good. We had to divide by negative 5, and I told you there's a way you'd never have to do that. I'm going to show you that soon for this problem. But the original said 20 minus 5 times my number is supposed to equal 65. Question mark to see if it does. They want me to put in negative 9. And so I go ahead and see what that does. It's got for me 20. I've got plus, right? The opposite of negative, that's 2 negatives on the term, making it positive. 5 times 9 is 45. That's 65. And it sure did it. And if you like that, that's terrific. I don't think you should quit though. I don't think you should say, I got this, I'm doing it this way. Because I want to show you another way. And it's a little bit weird the first time you see it. But boy, it over the years has paid dividends for students who go with it into the toughest battles. The problems that when I first started teaching, well, how to say this nicely, it wasn't you, but I didn't have confidence in a lot of my 094 E-level students many years ago getting problems like we're going to get to correct. Here it is though. 20 plus negative 5m equals 65. Now, I want to get rid of the worst bank balance. What? Exactly. Here's what's going on. That's the number 20, that's the number 5, and that's the 5m, that's the m term. Those are the only two on this side. Perfect. So I don't have parentheses, I don't have like terms to get rid of, but those are good. This is 65 is the only number term, and over here I'm going to put plus 0m. Now you got to be thinking, wait, come on. And I get that. But now I'm going to ask, if you look at the m, where our variables are, and that has 0, which exists, and that has negative 5, which is worse? Negative 5 or 0 for dollars in the bank. And if you're like, who cares, it's $5, consider them millions. I mean, it's got m's. This is worse. That's what we're getting rid of. Because we can't have m's on both sides, we're going to get rid of the worst one, which is the negative 5m is worse than the 0m. It's worse to owe $5 million than to have no money. Get rid of the worst one. This is gone. This is 5m. Look at that. The 5m is now positive. Don't bring down the rest yet. Lots of teachers bring down the rest of the stuff. I don't need you to do that. Because here's what happened. I worked to get 5m on the right-hand side. It happens to be the right-hand side. No big deal. Right or left, they both work. They both know the answer. But that scratch out means the other side, my right side, is going to have my m's. So my m's can only be on the right side, and this is going to sound very similar. Only m's can be on the right side. So not only are they only there, they're the only thing that can stay here. Therefore, 65's got to go. Negative 65, negative 65. And that goes. And what this creates nearly every time, unless it's an odd switch situation where you'll still survive but it won't do this, you'll get a scratch out on each side. One side scratching out the m terms, one side scratching out the number terms. 20 minus 65, subtract and get 45, but in this case it's strong on the negative. The equal sign is pretty long. What's in front of m is my interference of 5 times m. I will divide each side by 5. M will come along over here, and I'm comfortable with that, and this will divide to get me negative 9. You don't have to do it in 2 different lines when you've got that perfect, what I call a full house. Full house is it's got a number and an m term on that side, a number and an m term on that side, even if you have to put a 0m, or a number of 0 there to get it going. Then make sure that your m has a positive coefficient. So as necessary, I chose to add 5m as well as to add negative 65 to both sides. And now I have this that a lot of people say, hold on, that's backwards, you can't do that. That's perfectly fine. M is here, number is here. Divide both sides by 5 because m still has to be gotten alone, and I got that answer. For the same exact reason that it worked here as negative 9, it will work here as negative 9 when you go back to check it. I know it's weird. But by the end of just this lecture, you'll see why we want that weird stuff to work. And by the end of homework 8, I think those that go along with this concept of get rid of the worst bank balance, it sounds strange, but what it does is it creates the safest environment for you to work with these numbers. You'll never have double negatives. You'll never have to divide by a negative if you get rid of the worst bank balance. The work I've seen through the years of people pretty good at algebra, but not so hot at their work with arithmetic and negatives, benefits greatly by getting rid of the worst bank balance. It minimizes, it takes to the lowest point possible how many negatives you're going to have to deal with and all the risk that comes with them. Sometimes they stick around. Look at that. It came out as a negative answer. The 45 was negative. But look at here. You did what a lot of people traditionally do. Some people divide by 5 instead of negative 5. Some people even try to add 5. Having gotten so close, it doesn't close out well. Getting here, dividing by 5, okay, it's going to get your m alone because it's already positive. You don't see a minus to induce a plus. You don't see a plus to cause a minus, and you divide. So if you're ready to have it on either side, you can get the right answer. I find it a much safer approach. So that's why I've written it in the recipe terms that seem sometimes a little bit vague. It's okay. X over 5 plus 15 equals 0. Right now it looks like our target is 0. But this x over 5 is a positive term. There's no x's on this side, right? We don't have too much to go with here. If you want to put plus 0x, you know, you can. But we got 0 over there. It's pretty much nothing over there. This x is positive, that x is 0, so I want to leave, even if it's 1/5 of a dollar or 1/5 of a million, where am I getting that? I'm going to pull the x off the back. I'm going to have this. That's 1/5 x. Now 1/5 is positive, so if it's a 1/5 of a million or 0 millions, I'd rather have the 1/5 of a million. I'm going to leave that there. So I'm not going to move the bank balance. I don't have to. It's already good where it is. I'm going to get rid of the 15. I'm going to subtract 15 off the numbers of each side. 15 minus 15 is gone. This is still 1/5 x. And it equals, when we add 0 plus negative 15, it gets me a 15 that's strong on the negative. So write it again. 1/5 x equals negative 15. But now I'm going to go change the colors of what's up there. I've got this now that I've added negative 15 to both sides. I think negative 15 looks like my new target. Right, I said the target is kind of moving. It's over 1, sure. The interference is 1/5 times x. I'm going to write this down because it's something that needs revisiting across multiple lectures, I think. The interference is a fraction. It's multiplied by 1 over 5, right? That's my interference. I have a choice. I can go introduce division by a fraction and put myself through a lot of work that I don't need to do, or I can say the inverse to get the inverse effect of multiplying by 1/5, you multiply by 5 over 1. So let's see what we got here. We got the 1/5 space x equals negative 15 over 1 with space behind it. I'm going to multiply each side by 5 over 1. see what happens. This has become x. 5 over 5x, 1 over 1x, then 1, or you can divide the 5s each by that and you get 1x equals negative 15 times 5 over 1 times 1, which is negative 75 over 1. X equals negative 75. That's what I think my value is. We'll see. Does negative 75 work? Here we go. Over 5 plus 15 equals 0? Question mark. Get your calculator now if you need it too, right? This is negative 75. Negative 75 divided by 5. That's what that is. You can go negative 75, ABC 5, plus 15, and see what it is. I'm going to get it for you. But here's what it does for us. We got the 1 in front of the negative 75 that cuts the negative 75 free from the parentheses. Negative 75 over 5 plus 15. That is, we take our negative value of whatever 75 divide by 5 is. So I go once, I get 5, remainder 2, bring down the 5, 25, 15. Negative 15 plus 15, 0. Yes, negative 75, the answer to that thing. In this case, we had to get the number away from the x term. The 15 had to get away from the x term. The question was, do I want to stay with a positive 1/5 x, or do I want to go into negative 1/5 x? And I totally want to stay with positive 1/5 x. I don't want it to equal 0. I want x values on one side and numbers on the other, forcing them over there to become negative 15. Multiply both sides by 5. Negative 75 unlocks the door to the solution. Right? Negative 75 is what we got. It's going to get it to where we have both sides hitting the same number. The left side, when you use a negative 75 for x, becomes 0. The right side is actually locked in on 0. All right, here's where it starts to work for us. 5x plus 26 minus 3x equals 14. Now, knowing that you can roll back the video, I'm going to clear the rest of the board so you can focus on what we're doing on this problem and how it applies to how we're going to get this done. When we look at the notes we've written for how to do this problem, the first thing it says is get rid of parentheses if there are any. And we're fortunate here there are no parentheses, so that's good. We don't have to do that. But the next thing it does say is combine like terms on each side of the equation. So what you do is effectively you cover that up and you say, I'm not looking past that equal sign right now at all. I don't care if the target is 14 right now. I have to combine like terms over here. Therefore, when I take my 5x plus 26 plus negative 3x, there's an x term, there's a number, here's an x term. I bring negative 3x right here. What we've worked on before in combining like terms is essential to set this up in the format to solve the equation. So now that's not going to be written anymore that it's been checked, but I go 5x plus negative 3x, it's still x, and it's 2x, plus 26 has not been changed, and the only other thing is that it equals 14. Now, I want to leave my 2x here as positive. There are no x's over here. So I'm going to subtract 26. 2x plus 26 equals 14. Still have the target of 14, but I'm going to subtract 26. That's gone. 2x remains. I have to do 14 minus 26, so I have to do my subtraction. Since they don't work together, they work against each other. I'll get 12. But it's strong on the negative. So combining like terms made this into 2x minus 26 equals 14. Subtract 26 off both sides. Let's now divide both sides by 2. 12 over 2 is 6. So we think the answer is negative 6. We go to the original. 5 times my number plus 26 minus 3 times my number is supposed to equal 14. My number goes in there twice as negative 6 in parentheses. I don't want it to look like 5 minus 6. I don't want it to look like minus 3 minus 6. I want this to be plus, and I want negative 6 there, and I want negative 6 there. There's my plus sign right there. Is there? Ready? Okay. Let's see what we get. 5 times 6 with a negative, negative 30, plus 26, plus 3 times 6 is 18, pair of negatives is even, so we're going to have positive 18. This is going to stay as the only negative, plus 26 and 18 added together. 14, 1, 44. Now I have 44 and negative 30, so I have 44 and 30, and I'm going to do the subtraction. I'm going to get 14. And it's strong on the positive like the 44, and it sure did hit my target, which I knew all along to be 14. My answer here, x, my solution, is negative 6. You see, the 14 as a target is just to confirm that negative 6 is what we look for as the perfect number to work this out. Now, this next one has everything that we can go with. I'm going to go with 3x plus 4, 3 times x plus 4 equals 7x, well, 7 times x minus 5 plus 11. And they can get more extensive, but this uses everything. This uses the distributing. This uses the combining of like terms. This proceeds to see where we can get rid of the worst bank balance and have the problem work out positively. Now, on this one, I didn't have a lot of temptation about what I should do with x because I don't really have many threats from negatives. But I want to go over there and show you how to avoid the negatives by getting rid of the worst bank balance. That does not happen until all parentheses are gone, generally through distributing, and each side is fully simplified. So what happens here is this is 3 times 1x plus 3 times 4. This is 7 times 1x plus 7 times negative 5 plus 11. Let's get this side all the way done. 3x plus 12. And it has no like terms. And it's standing on its own for now. So I go with equals and I just don't even look at that anymore. This is 7x plus negative 35 plus 11. That does have like terms. I don't have anything to do with bringing things across the equal sign right now. This is 7x, that's my first number, that's my second number. Plus 11 stays exactly as plus 11. Nothing has changed from the way we combine like terms. It is still an important part of what we do. So this doesn't have any like terms, so that gets to stay for now as 3x plus 12. This one is 7x, and then I have to do 35 is negative and 11 is positive. So I take my 35 and 11. The 35 is higher up. And I decide they work against each other because that's positive, that's negative. So I subtract, and I get a 4 and I get a 2. So I get 24. But the stronger one is negative, so I have that. Okay, so what I've done here is created a full house. The left side has an x term and a number. The right side has an x term and a number, which is a perfect configuration to get rid of the worst bank balance. I'm going to advise you that many teachers would say, okay, bring the x's to the left, bring the numbers to the right, and we'll just deal with it because we're all awesome and don't make mistakes with our negatives. And I don't believe that to be true. I wish it were, but it's not. So they would say subtract 7x off both sides, and we'll do that over here after I show you what we're supposed to do over here. And we'll see the mistakes that they invite as possibilities. What I say is get rid of the worst bank balance. For x, this is 3, and this is 7. Which is a worse bank balance, positive 3 or positive 7? And I deal with bank balances because of when negatives show up. And I want to show you one of those before we stop here today. And 3 is worse. That's the one that's got to go. So I say, you know what? You got to go. Negative 3x on both sides. That's gone. This is not going to be written as 12 yet, but this is 4x. The x's are done. The x's have taken over the right side as 4x. Now here's my equal sign, and here's the two important things to know. In this case, I made a decision that my x's can only be on the right side, and only my x's can be on the right side. So I'm going to go here, and this negative 24 got to go. Plus 24, plus 24. And then I add those, and I get 36. Now I see 4x, right? I got 36 equals 4x. I divide each side by 4, and I get my x equals 9. We'll see if it works, right? We've got 3 parentheses plus 4, and then we're supposed to have that equal with a question mark, 7 parentheses number minus 5, close plus 11. In the parentheses, I have to drop an x, which is the number 9. I'll put my 9 in there with parentheses, I always do. Turns out they don't need the parentheses here, but having them doesn't hurt. Missing them when you need them, ouch. Okay. This is 3 times 9 plus 4, because 1 times 9 made it free from the inner parentheses. And this is now 3 times 13, which is 39. So that's my target. I finally know the target that I've been hunting for this whole time. Apparently is, if I use a 9, the target needs to be 39. Now I have 7 times 9 minus 5, 9 plus negative 5, and then plus 11. I have 7 times 4 plus 11, which is 28 plus 11, which is 39. And because the targets hit each other, 9 is my solution. Now there can be things with fractions and all that come along. There could be more than one like term on each side for each column and stuff like that. But looking at my instructions, it made use of every step. Now I want to take you through using only blue, doing what another teacher would have you do. Once you've gotten 3 times x plus 4 equals 7 times x minus 5 plus 11, right? 3x plus 12 equals 7x minus 35 plus 11. Okay, that's what they've got. Not everyone says the next thing you should do is combine like terms on each side. I disagree, and I'm going to say let's go with that. Even if you want to ignore my advice about getting rid of the worst bank balance for x, I think we should move that 11 over here. So we got 3x plus 12 equals 7x, and then we do that out as minus 24, and there will be. Okay. I do not like, and I do not think you should do, having people kind of, man, I don't even, but all right. I'm going to subtract 11 up. Wow, see, it's very confusing to look at some of what things that other people do, but they might say, bring the 7x over by doing minus 7x on both sides, and bring the 12 over by doing plus 12 on both sides, and still having those in categories like that. That's pretty ugly, right? When we get the chance to make this into 2 terms, let's do it. And this is 2 terms, it's good, but if it wasn't 2 terms, let's do it by getting the like terms together. If you go the old school method, no judgment on the nuns, but when I was taught this way in Catholic school, you must bring the numbers to the left side, you must bring the x's to the left and the numbers to the right. Okay, so what they're saying is, get all your x's over here, so they're saying let's minus 7x. And this will be gone, and you know you're not going to get the negatives ever wrong in your entire life. I'm being sarcastic, but anyway, this is x, and that's negative 4x plus 12 equals negative 24. You say, now this, you need to get that number by itself, that x term by itself, as I've been saying since earlier. So they're saying now is the time to subtract the 12. So that this is gone, and I have negative 4x is equal to, do you add those up? You don't get a 12, you get a 36. Well, that's good. Do you know it's negative and not positive? Well, that's good, but both are possibilities of mistakes you can make. Now, do you add 4 to both sides? Another mistake you might make. Or do you divide both sides by 4? Also a mistake has been made. You need to divide by negative 4. And if you did all that, you'll get x equals 9, which will work the same way as mine did to the answer. But what I do is this. When I get that here, I definitely combine like terms to get to this anyway. 3x plus 12 equals 7x plus negative 24. I will hear arguments that there are easier ways, but make sure that the argument that you give me is not, oh, I've already done it this way once in the past and I got through it okay. Just because you've done it in the past doesn't mean in the long run it's easier or better for your foundational math skills. And there's a lot of ugliness. I won't see your work unfortunately, unless we get working in, online extra help, I won't really see the work that you're doing. So it's hard for me to trust that you're not still doing the old things that teachers taught you. But if it works out perfectly every time, I'm going to say that's okay. You're just not building as strong a foundation for your next math course as if you build it based on, let's really focus on getting x's on one side, numbers on the other, and while we have the choice, why don't we keep the coefficient of x positive? Because some people say like x can only be on the left side and I'll deal with the negatives as necessary. That is very closed-minded and very risky. If you say x can be on either side and I'll think ahead of time to avoid use of many negatives, that's very freeing in many cases that I've seen. So this will wrap up the lecture, but I'm going to say this lecture was about getting you into the concept. Homework 8 is one of the most important homeworks of the semester. And my homework 8 video covers almost every single problem in the homework because every little thing that pops up is purposely put in to that homework. And then I go over it in the homework one. So the homework video, you look at number 8, is going to be a long one in terms of time and content. But do take a look at that if you have any problems getting through it, like, wait, what do I do for, how do I know which x to get rid of? That's all addressed problem by problem in the homework 8 video. So make sure you spend some time on homework 8, try and get 100 on it your first time, and if you do, that is awesome. But most people will not, and then you watch the video for it, and particularly go and looking for things that are very similar to the problems you're dealing with, and give that a shot.